This video is part 2 of the law of signs notes, the ambiguous case, when the information is given to us in side angle format, okay? Now, in this problem, we've got angle A is 61 degrees, side A is 32 miles, and side B is 35 miles, okay? So the first question is how many possible triangles exist. Now, we talked about there are 7 different scenarios here, and this scenario is going to be a case where we have 2 given triangles. Now, because angle A is acute, and because the side opposite A is smaller than the other given side, 32 is smaller than 35, that means there's a possibility here of either no triangles existing or 2 triangles existing. Okay, without getting too deep into those 7 scenarios, let's just work it out and see what kind of happens here. Okay, so first thing that I'm going to do is find angle B. Okay, we've got angle A, we've got side A, we've got side B, so I want to find angle B first. So I'm going to write my equation using those ratios. Cross multiply, divide by 32 to get sine B by itself. Evaluate this ratio, find out exactly what that equals. Again, just like in part 1 of the video, we want to take this out at least 6 places. The more you take it out, the more accurate your angle for B is going to be. We got to use the inverse sine, okay? And we get an angle measure of 73.06 degrees. Now that fits based on the given information here. We know angle B has to be larger than angle A because side B is larger than side A. Okay, so this is going to be one of the triangles. So this tells me that there are, are going to be 2 triangles based on the information highlighted in yellow here. Okay, use geometry to find the measure of angle C. Okay, plug in the one we know, and we get angle C is 45.94 degrees. Okay, next thing we want to do, use our law of sines ratios. We've got excuse me, A over side A equal to C over sine C. All right, cross multiply. We're going to divide by sine 61 this time, and we're going to get our value for side C. Okay, so that's one triangle that's going to fit here. Okay, one triangle is going to fit. There's another angle measure for B that has this same trig value here, okay, the same ratio, 0.956615, okay? So we know there's a second triangle here because there's a second angle that has the same trig ratio here as this 73.06 degrees, okay? If you were to do the sine of 106.94 degrees, you would get this same value here, okay? We know the sine is positive in the first and second quadrant. When you see this value, it tells me that there's 2 angle measures that have that same trig function. Now, we know B is going to be the largest angle now based on what we saw here, okay? It's okay that it's acute, that it's obtuse here. It was acute here. It's okay that it's obtuse because it can still fit within the 180 degrees that a triangle has, okay? So, we've got angle A, we've got angle B, we can find angle C using geometry. Okay, so now angle C is going to be a little bit different as well. We've got 12.06 degrees. So if we add 12.06, we add this 106.94, we add the given 61, we get to 180. So that's why a second triangle can exist here. Now we're going to use the law of sines to find side C. Okay, so 32 over sine 61 equals C over sine of 12.06. Cross multiply, divide by sine 61, and then use your calculator to evaluate the side length for C. So in this case, in the second triangle, side C is going to be 7.64 miles. Okay, so there's 2 different triangles. Okay, this was our first one. We had the 3 given values, and we calculated these other 3 values. That will work. Okay. Also, there's a second triangle, the 3 given values, and these 3 values will also work. Okay, so based on this scenario, there are 2 triangles that will work.